So if I start off squaring each side so that I can figure out where those curves meet, square root squared, which is going to be an x, 1/2 squared is 1/4 x squared. Set it equal to 0. So we could factor out an x here. You set each of those equal to 0, you get x equals 0 and 4. So let's get our graph. I'm going to start with the square root. Alright, so square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. I'm going to go ahead and do the square root of 3 is, sorry, square root of 9 is 3 because this tells me I'm going all the way to 9. Here's my square root graph. Y equals 1/2 x. 1/2 times 0 is 1/2. 1/2 times 4 is 2. So we know that's where they meet. If I put in a 2, for instance, 1/2 times 2 is 1. If I kept going, if I put in like 6, 1/2 times 6 is 3. If I put in a 9, 1/2 times 9 is 4.5. So this one is a line. Mine isn't very straight because I didn't draw perfectly to scale, but we get the idea. And then I'm stopping this at x equals 9, which is a vertical line. So when we integrate, the top curve switches. So we're going to have to break this up. So I can start out and go from 0 to 4. Between 0 and 4, which curve is on top? The square root. So the square root of x, or if you prefer, you can write that as x to the 1/2, minus the bottom was the 1/2 x. Okay. Then after 4, it switches, and we're only going to 9 because it said to stop at x equals 9. And on that section, the 1/2 x was on top, so you would do 1/2 x minus the square root of x, or if you want to write that as x to the 1/2 top. So we have to break this up because the top and bottom switch places. There. Can you guys finish it from this point? So you're ready just to integrate and evaluate from there. Okay, so then I told you I wanted to talk about 35 together. So we have okay, if you read the directions on these, it says use a graph to find approximate x coordinates of the points of intersection. These don't meet at nice points. So obviously this wouldn't be one that I would give you on the test because we have to use our graphing calculator to do it. But I wanted to kind of show you it doesn't have to always be nice, pretty intersection points. So we're going to do it on our calculator. So grab a graphing calculator. Go to your y equals, and then plug in the first.
Here, I'm here.
So my y sub 1 should be the 3x squared minus 2x. My y sub 2 is the x cubed minus 3x plus 4. here's my first one, a parabola. And then we have a cubic. Okay, so we have to find the points of intersection. If I'm trying to get those exactly, what do we have to do here? You guys remember?
Some use a calculator.
Yeah. We go to second, trace, and number 5, intersect. Okay, we're gonna find this first point to start. First curve, just hit enter. Second curve, hit enter. Guess, you have to take it close to the point you're looking for. And hit enter.
Wait, how do you do
What do you mean? Where? So, are you sure?
Yeah.
So,
Yeah, we'll have to trace.
okay, number 5, intersect. Then it's gonna ask you questions. It says first curve, just hit enter. Then it'll say second curve, just hit enter. And then it asks for a guess. So go close to that first point we're looking for. And hit enter. So it tells me my intersection is negative 1.1149. I think I did, just kind of looking at my answer key, I did 3 decimal places on this. It didn't really specify. So we're going to do maybe 1.115. Okay, now we need to find when this stops. So we have to find this next intersection. So we're going to do the same thing. Second, trace, except my calculator froze, so I can't do it up here for you. So go to second, trace, intersect, which is number 5. First curve, hit enter. Second curve, hit enter. Guess. We need to get close to this point right here. And where'd you get?
1.2540.
Okay. In that section, which curve is on top?
X cubed.
The x cubed. Okay. Now here's the thing. That is not the only place they meet. There is another. This next one starts at the place where that left off. 1.254. Then we need to find that next place where they meet. So go to second, trace. See if mine will work yet. Intersect, number 5. First curve, enter. Second curve, enter. Guess. I need to go past this point. It's way up here where they meet, so I'm just going to kind of keep going up a little bit and hit enter. And it tells me that point is 2.861. Okay, so from that section, the blue one is on top. So you have to do the 3x squared minus 2x minus the other one. So this one is definitely going to be a little bit uglier. You can like kind of combine some like terms first, but you're definitely going to want to use a calculator to plug all this stuff in. Don't try to do it all by hand. So you can combine my terms and then integrate. But we've got the whole thing set up for you. Now you just have to do the integration piece and plug in. So 2 of them we've set up and got you to that point. We have 4 minutes. Are there any others that you want me to talk about before the end of class?
46.
Okay. So problem 46 tells us the birth rate and the death rate. I want the area between the curves for 0 less than or equal to t less than or equal to 10. So we're going to integrate from 0 to 10. Okay, top minus bottom. Which one do you think is higher, birth rate or death rate?
Birth.
Probably birth rate. So we're going to put the birth rate, which was minus the death rate when you integrate this, guys, e to a power doesn't change, but you have to think about the chain rule in reverse. That 0.024 would come down. So your coefficient would be 2200 divided by 0.024. So this one would be 1460 divided by 0.018 when we do the chain rule in reverse. And this would be another one I've integrated for you, so now all you have to do is plug in and evaluate. And then it does ask you what this represents. So when I get this final number, what do you think that number is going to tell me?
What's the population group?
Yeah, the amount of population group. And if it turned out to be negative, what would that tell me? The population decreased during that time frame. So all you have to do, I've set up 3 of your 10 problems for you, so you just have to plug in now and evaluate that.